Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan juga selamat tengah hari kepada semua. InsyaAllah sekali lagi kita bertemu untuk sesi perkuliahan secara segerak untuk kursus PRM 1026 Matematik 2. Okey, kita balik semula ke atas talian. Internet terputus seketika. Jadi sekarang ini kita dah kembali ke semula ke atas talian kita. Jadi sekali lagi diingatkan kepada semua akan ada sedikit delay untuk apa yang kita akan paparkan secara live ataupun secara langsung hampir kurang 10 hingga ke 16 saat. Jadi mohon anda semua untuk bersabar berkaitan dengan perkara tersebut. Sila gunakan ruangan Q&A dengan sehabis baiknya. Gunakan ruang dan masa ini untuk anda selesai ataupun rungkaikan permasalahan yang melibatkan LU yang kedua iaitu Application of Differentiation. Tepat jam 2 petang, Encik Ibrahim akan terus bersama dengan kita untuk menyampaikan sedikit perkuliahan secara maya. Namun begitu soalan-soalan anda insya-Allah akan kita terus jawab dan juga usaha untuk responkan sebanyak yang boleh. Okey. Jadi sila perhatikan di ruangan Q&A publish untuk pastikan yang soalan yang anda tanya itu tidak ataupun belum ditanya oleh rakan-rakan anda yang lain. Jadi sekiranya anda bertanyakan soalan yang sama, insya-Allah saya akan reply terus kepada anda menyatakan yang soalan tersebut sudah pun ditanya dan sebagainya. Dan nota-nota berkaitan dengan jawapan yang akan diberikan oleh Encik Ibrahim kepada anda semua, insya-Allah saya akan cuba typekan di setiap ruangan soalan yang telah pun dipublishkan. Kita mohon jasa baik semua untuk sama-sama memberikan peringatan kepada rakan-rakan anda untuk menyertai sesi ini kerana kehadiran adalah wajib. Okey. Dan jika anda sudi, silalah publish soalan tersebut ataupun sila lontarkan soalan anda bukan sebagai anonymous tetapi dengan nama anda sendiri. InsyaAllah kita sangat-sangat menghargainya. Okey. Jadi dengan itu saya akan berhenti seketika di sini. Untuk makluman semua, Encik Ibrahim mempunyai sedikit technical issue berkaitan dengan speaker. Jadi saya akan berhenti segera. InsyaAllah saya akan berkomunikasi dengan beliau menerusi ruangan WhatsApp di tepi dan sebagainya lah. Okay. Jadi hope you enjoy our lesson for today and do stay safe and stay entertained.
Okay, Assalamualaikum dan selamat petang semua. Okay, LU2 application of differentiation. Okay, jadi last week saya dah bagi soalan, ada 5 soalan untuk 2.1 equation of tension and 2.2 extremum problems. Okay, question 1 saya teruskan saja. Masa kita tak lama, sekejap saja. Okay, question 1, find the relative maximum and the relative minimum point using the first derivative test. Fx equals to the 4x cubed minus 3x squared. Question A. Okay, first you find the first derivative of the cubic function. Fx here equals to the 4x cubed minus 3x squared. So you'll find the first derivative, differentiate y with respect to the x, 12x squared minus 6x. Here is the first derivative of the cubic function. And you let the first derivative here equal to the 0. So here, the stationary point of the cubic function here exists when the first derivative equal to the 0. Yeah, 12x squared minus 6x equal to 0. And here equals to the 6x times 2x minus 1. And the first value of x here equal to 0. And second value of x here equals to the 1 over 2. Yeah. Okay. So this one, first step, you find the first derivative and find the value of x. X here equal to 0 and x here equals to the 1 over 2. Yeah. Step 2, table of a shape of tangent. Okay, so you draw the table. The first row here, you put the value of x here. Okay, and the second row, the sign of the first derivative, f prime of x, and here the shape of tangent, SOT. Yeah, so the first value of x here, when x here equal to the 0, so this value you put at the center of the table. Letakkan di bahagian tengah. Yeah, this one, you put your 0 here. And you substitute 0 into the first derivative and answer here 12x squared minus 6x, answer here equal to 0. Yeah, and the sign of the first derivative when the f prime of x equal to 0, so this one you put the horizontal line. Yeah, and when the sign of the first derivative here positive, this one you put the shape of tangent increase, INC. And this one, when the sign here negative, so here you put the sign of tangent decrease. Kita ada 3 sign saja. Sama ada horizontal line, increase positive, or the negative sign. Yeah. So here you put the value of x here, the sign here equal to the 0. Okay. So sign here equal to 0. So at the center here you put the horizontal line. Yeah. Okay, and from the left of the function, this one, the nearest value between negative infinity and x equal to 0. So here you pick the x equals to the negative 1, yeah, and substitute into the first derivative. This substitution, you all just gunakan calculator, tak perlu tunjuk. Okay, yang ini ya. This one just gunakan calculator saja, yeah. So negative 1, the first sign here positive, and the shape of tangent here increase. Yeah, and the third column, the nearest value here equals to the 0.25. Yeah, 0.25, and here the sign here equals to the negative, and the shape of tangent here decrease. Yeah, this one, if you pick the value of x here equals to the 1, so the sign of the first derivative here equals to the 6 positive. Yeah, Jadi nanti ambil yang paling dekat. Kalau tak boleh 1, you ambil maybe 0.2, 0.3 ataupun 0.1, the nearest value. Yeah. So this one you combine all the three shapes here. So shape of tangent here with the relative maximum point. Okay, sama saja. Okay. This one, step 2, draw the table of a shape of tangent. Okay, this one your answer. Okay. And when x here equal to 0, you substitute into the cubic function and find the value of y. Y here equal to the 0. Yeah. And answer you here, 0, 0 here is the relative maximum point. Okay, first point at the origin. And the second point, when x here equals to the 1/2. This one saya bagi jawapan. You all check. Okay, the second value of x here equals to the 1/2. Okay, and the first row here, the value of x. Second, the sign of the first derivative, and then here is a shape of tangent, sama saja. So the 1/2 from the left here, 0.25, and here between 1/2 to the positive infinity, the nearest value x here equals to 1. Yeah, and the shape of tangent, decrease, horizontal line, and increase. So here you combine. So conclusion you here, the relatives minimums point, yeah, at the 1/2, yeah, and substitute 1/2 into the function, and y here equals to the negative 1/2, and last conclusion, 1/2 negative 1/2 is the relatives minimum point. Okay, mudah saja, yeah. Okay, settle question A and question B. Ini saya tunjukkan method saja. You all check. Method using the first derivative test. Okay, step by step. Okay, you all check. Step 1 here, you find the first derivative. Differentiate y with respect to the x. You let the dy over dx here equal to the 0 and find the value of x. Yeah, this is step 1. Okay. And step 2, the table of a shape of tangent. So you draw the table. The first row here, you put the value of x. Second here, the first derivative. And the third row here, shape of tangent. Okay. And step 3, you find the coordinates of the stationary point. Yeah. The value of x here, you substitute into the function. Okay. And then value of x and y. And last year conclusion, the relative maximum or the relatives minimum point. Yeah. Jadi nanti untuk first derivative test, you all ada 4 step yang utama daripada step 1, step 2, step 3 and step 4. Buat step by step lagi mudah. Yeah. Okay. And here the shape of tangent. Shape of tangent, first from the left here, graph increase, horizontal line and decrease. So conclusion you here point with the relative maximum point. This one the first relative maximum. Second here decrease, horizontal and increase. And here the relatives minimum point. Yeah. So number 1 and number 2 stationary point of the function here exists with the relative maximum or with the relatives minimum point. Yeah. Number 3 nilai sikit. From the left here, increase, horizontal and increase. So you combine this one, the graph of the cubic function. Yeah. So the stationary point of the function here does not exist. This one you already check. No maximum and no minimum point. Yeah. Yeah. Dia nak check dia mudah saja. You all just compare the shape here. Kalau you dapat U shape, sama ada U macam ini, this one the minimums, ataupun U terbalik, you akan dapat maximum point. Jadi kita ada dua shape saja kalau dia exist, sama ada maximum ataupun minimum saja. This one stationary point does not exist, number 3. And number 4 here, decrease, horizontal decrease, stationary point here does not exist. No maximum and no minimum point. Ya, mudah saja. Okay, question B, you all check answer. Question B, saya ambil soalan dalam slide question B itu, sama saja. Soalan sama, you all check dia punya solution. So here, your first step, you find the first derivative of the rational function using the quotient rules. Yeah, you check the value of u, value of v, and the first derivative here equals to the x square minus 4 over x square. Yeah. Okay, and you let the first derivative here equal to 0. Value of x here equals to the plus minus 2. Okay, check answer. Okay. And then step 2, table of shape of tangent. The maximum point here exists at the -2, -4. You check answer sahaja. Okay. And then 2, 4, the relative minimum point. Okay. Okay, settle. Question 1B. Okay, question 2. Find the coordinates of the stationary point using the second derivative. A, y here equals to the x cubed minus 3x squared minus 24x plus 32. Okay, so given the cubic function, y here equals to the x cubed minus 3x squared minus 24x plus 32. Yeah, and first step, you find the first derivative of the cubic function. Okay, so you differentiate y with respect to x, 3x squared minus 6x minus 24. Okay, first derivative. And you let the first derivative here equal to the 0. Okay, so the stationary point of the function exists when the first derivative here equal to 0, 3x squared minus 6x minus 24, and you move out the constant 3 times x squared minus 2x minus 8 and equal to 0. Yeah, and you factorize the quadratic function, x plus 2 times x minus 4 times 3, and here equal to 0. And find the value of x. X here equals to the -2 and x here equals to the 4. Yeah, this one step 2. Yeah, you let the first derivative equal to 0 and find the value of x. Yeah. Okay. And step 3, you've got to find the coordinates of the stationary point. Yeah. First point here equals to the -2, and you substitute into the cubic function. Yeah. The value of y here equals to the 60, and the first stationary point at the -2, 60. And the second point, x here equals to 4, and you substitute into the function, and y here equals to the -48, and the second point here at the 4, -48. Yeah. Step 3, you find the coordinates of the stationary point, the value of x and the value of y. Okay, and here step 4. Step by step. Okay. And first here, you find the second derivative of the function. Second derivative here equals to the 6x minus 6. Yeah. And using the second derivative test, determines the relative maximum or the relative minimum point. You substitute -2 into the second derivative. Okay. And here answer -12 minus 6 here equals to the -18. Or answer you here less than 0. Okay. And the sign of the second derivative here negative. And conclusion -260 here the relative maximum point. Yeah. Okay, first point x here equals to the -2, and the second point x here equals to 4. Okay, substitute into the second derivative sama, and answer here equals to the positive 8. So sign here positive, and then 4 -48 is relative minimum point. Yeah, jadi you all ada 4 step kat sini. Yeah. Second derivative ni paling mudah. You all nak check dia punya answer mudah saja. If the sign of the second derivative here negative, so conclusion you the relative maximum point. Yeah. And the sign here positive, and conclusion you here the relative minimum point. Dia mesti terbalik. Negative maximum, positive minimum point. Mudah saja. Yeah. Okay. Question A. Question B and C, you all punya homework. Ada jawapan kat situ. Method dia sama sahaja. Okay, so step. Ini saya tunjukkan step by step. So you all check step. Second derivative test. Step 1 here, you find the first derivative of the function. Yeah. So first derivative of the function here equals to the 3x square minus 6x minus 24. Okay. Ini yang tadi ya. You all check balik. Okay. So step 1, first derivative. And then step 2, find the value of x. You let the first derivative here equal to the 0. Yeah. And then step 3, find the coordinates of the stationary point. Substitute x into the function, and you find the value of x and the value of y. And step 4 here, using the second derivative test, determine the relative maximum or the relative minimum point. Yeah, this one step 4. And last here, answer you maximum or the minimum point. Yeah, dia ada step 1 to step 5. Mudah saja. Yeah. Okay, so second derivative test. This one you boleh check. Okay, first here sign of the second derivative greater than 0, or here positive sign. Yeah, and conclusion here the relative minimum point exists, and you draw the smile face. Ini saya tunjukkan dalam slide pun ada. Kalau dia positif, dia akan smile face. Okay. And the second derivative here less than 0, or sign here negative. Okay, and you draw the set face, and here the relative maximum point. Sama saja, ya. Dan satu lagi kelas, when the sign of the second derivative here positive, you punya graph here concave upward. Okay, CU. This one you punya smile, jadi dia akan CU, dia akan concave upwards. Okay, and less than 0 here negative, set face. So this one you punya graph here concave downwards. Yeah. Okay. Question number 3. Inflection point. Okay. Question number 3. The graph of the quartic function, you state the inflection point. This one you all tandakan sahaja. Ini soalan CLO1, ya. Ada 2 markah saja, ya. Ini saya tunjukkan jawapan. Okay, check answer. Okay, so graph here from the left of the function between negative infinity and negative 1. Check first interval, start from here. So graph here concave up, CU, yeah. So graph here concave up, and after negative 1 here, graph concave downwards, okay. Between negative 1 and positive 1, graph here concave downwards. Okay, CD. Okay, and here the inflection point here exists at the negative 1, 1. Okay, this one you punya first inflection point, number 1. Okay, and second, between negative 1 and positive 1 here, graph concave down, CD. And after positive 1, graph here concave up, CU. Yeah, ini saya tunjukkan juga. So this one the inflection point at the x equals to 1 and the y here equals to 1. Yeah, ini saya just estimate saja value dia. Tapi the exact value nanti kita akan bagi. Yeah, okay. This one second inflection point, and the number 3. Between 1 and x here equals to 3, graph here concave up, and after 3 here, graph concave downwards. Okay, you all boleh check. This one CU CD, and here the inflection point at the 3 1/2. Yeah, kalau you all check kat sini ada 3 sahaja. Dia mesti ada mudah saja. Konsep dia mesti ada from the left here, maybe you punya CU, and then this one the inflection point, you ada CD. Okay, this one first. Okay, number 1. Ataupun number 2 from the left here, graph here CD, and then between here inflection point, and then after point here CU. So this one pun inflection point exists. Yeah, salah satu daripada dua ini, sama ada ini ataupun ini, baru you punya inflection point to exist. Yeah. Okay, question 4. Question 4, find the coordinates of the inflection point of the cubic function e equals to the y equals to the x power 4 minus 4x cubed plus h. Question A, graph of the quadratic function. This one you all check. X power 4 quadratic function. And then x cube, here the graph of the cubic function. Ini kita next week kita akan masuk. And the graph of the quadratics here, power of 2. Okay. Okay, question A, x power 4. Okay, so given the function y here equals to the x power 4 minus 4x cubed plus h, and here you find the first derivative of the quadratic function. Differentiate y with respect to the x. First derivative here equals to the 4x cubed minus 12x squared. Yeah, and the method using the second derivative. And here you let the second derivative here equal to the 0. Okay, and you find the second derivative, 12x squared minus 24x. Okay, this one you punya first derivative fd, and here the second derivative of the quadratic function. Yeah, so you let the second derivative here equal to 0. So here inflection point here exists. When the second derivative equal to 0, 12x squared minus 24x equal to 0, and you move out the 12x times x minus 2, and the value of x here equal to 0, and x here equals 2. Yeah, This one, first derivative, this one the first step. And the second derivative and find the value of x here, step 2. Okay, kita buat step by step. Okay, step 1 first derivative, step 2 second derivative, and you let equal to 0 and find the value of x. Okay, and step 3. Okay, step 3, find the coordinates of the inflection point. So the first value of x here equals to 0, and you substitute into the quadratic function, and the y here equals to at, yeah, and first point here at the 0 at, submit this one number 1, and the second point x here equals to, and you substitute into the quadratic function, and y here equals to the negative at, and the point here at the 2 negative at. Okay, this one the quadratic function. Kalau graph of the cubic function, saya tulis. Okay, kalau graph of the cubic function x cube, biasa dia you all cuma dapat satu point sahaja, ya, point of inflection. Kalau quadratic function, kebiasaannya kita akan dapat 2. Itu perbezaan dia. Okay, nanti you all boleh check minggu hadapan. Okay, dalam curve sketching. Okay. Step 3, find the inflection point of the quadratic function. Okay, and step 4, you draw the table of concavity. Yeah, so the value of x here equal to 0 and x here equals to. Okay, first, before you sketch the tables, first here domain of the quadratic function defined for all the real numbers, negative to the positive infinity. So here you draw the number line between negative infinity to the positive infinity. Yeah. So the value of x here 0 and 2. So from the left here, the value of x may be here 0, and the second value positive 2 may be here. Yeah. So the first row, the first intervals from the left of the function, negative infinity, x equal to 0. Second here between 0 to, and the third interval here 2 to the positive infinity. Yeah. So 3 interval. So you put the first interval from the left, negative infinity 0. So first column here, first interval. Second, you put the 0 2. Okay, and number 3, 2 to the positive infinity. Okay. Okay. Okay, so you draw the tables. First row here, intervals of the function. And the second row here, sign of the second derivative. And number 3, concavity of the function. Yeah. And the first intervals, negative infinity 0. Yeah. So first value of x, saya tukar color. Okay, so the first value of x here, the nearest value, maybe x here equals to the negative 1 from the left. Okay. Okay, so first value, the nearest value from the left here, negative 1, you substitute into the second derivative, 12x square minus 24x. This one you pakai calculator saja, tak perlu tunjuk. Yang penting you punya table ni penting, ya. The answer here equals to the 36, ya. Okay. And the answer here equal to 36 and the sign of the second derivative here positive, yeah. So here you put the positive sign, first column positive, and when the sign here positive, so graph here concave up CU, yeah. Okay. And the second interval between 0 to the nearest value you put the picks the positive one, sama. And this one x here equals to 1. You substitute into the first derivative and then sign here negative. And here graph here concave downwards, CD. And last 2 to the positive infinity, the value of x here equals to the 3, the nearest value. Yeah, you substitute and then answer you here equals to the positive sign. Yeah, positive. So graph here concave up CU. Okay, ini saya nak tunjukkan saja sign of the second derivative here positive. So graph here CU. Ini jangan terbalik ya. And sign here negative. Graph here concave downwards. Kalau you all nak mudah ingat positif, dia mesti akan senyum, smile. Okay, negatif, dia akan dapat sad face. Mudah saja ya. Okay, settle. Okay, step 4, table of concavity. And then you check your tables. Okay, so tables here from the left between negative infinity 0, 0 to this one concave up, and after 0 here graph concave downward. So this one you all first inflection point. POI. So inflection point here at the 0 8. And second, first interval 0 2 CD. And then this one, the value of x here equals 2. And after 2 here, graph concave upwards. Okay, you check the sign here, positive, negative. So between here inflection point or negative, positive. And here the inflection point at the 2 negative end. Yeah. Yang mudah saya nak check. You all check dia punya CUCD ataupun you all boleh check dia punya sign ini sama ada positif negatif ataupun negatif positif. And conclusion you here, inflection point at the 0 8 and 2 negative 8. Okay, and here dia punya method. Method to find the inflection point. Okay, you boleh check step by step. Okay, so the first step here, find the first derivative of the quadratic function. Ini yang tadi ya. Find the first derivative, differentiate y with respect to the x, dy over dx. And here step 2, you find the second derivative and let the second derivative here equal to 0 and find the value of x, step 2. And step 3 here determines the coordinates of the inflection point. Substitute x here into the function and find the value of y. Yeah, this one coordinate of the inflection point. And step 4, table of concavity. First row here you put the interval of the function. Second here sign of the second derivative. And number 3 the concavity of the function. Dia hampir sama dengan first derivative. Kalau first derivative, first row here the value of x. Second here sign of the first derivative, and number 3 shape of tangent. Yeah, and last here step 5 inflection point here exists or does not exist. Ada 5 step saja. Yeah, step 1 to step 5. Okay, so here first sign of the second derivative and the inflection point. Ini saya tunjukkan perbezaan dia. Okay, first here when the sign of the second derivative negative, so graph here concave downward CD. Okay, and the positive sign graph here concave up. So you combine here and you akan dapat nanti cubic function and the inflection point here exists. Okay, this one first graph. Okay, and second from the left here, first interval, second derivative here positive. So graph here concave up, CU. And then second interval here, second derivative here equals to the negative. So here CD. Okay, and here inflection point here exists. Okay, sekali lagi ya. Dia mesti ada, mudah saja konsep dia. Dia mesti ada CD and CU ataupun CU and CD. Dia mesti ada up and down ataupun dia mesti ada positif, negatif, sign dia berubah, negatif, positif ataupun positif, negatif. Ya. Okay, number 3. Ini ada sikit pembetulan. Okay, number 3, from the left here, first interval, positive sign. So graph here concave up, CU. And then second point here, second intervals, graph here concave up. Ini mudah saja. You all combine. So from the left here concave up. Okay. And after x equals to a here, graph here concave upwards. Yeah. So this one CU. And then after point x equals to a, graph here CU. So conclusion here, inflection point here does not exist, D and E. Yeah. Okay, number 3 and number 4. Okay, ini pun sama. So from the left here, sign here less than 0. So graph here concave downwards, CD. And the second interval negative and graph here concave downward, CD. You all combine. So from the left here concave down and then here concave downwards. Yeah, dua-dua down. So in conclusion you here inflection point of this function D and E does not exist. Okay. Next week kita akan jumpa. Ada masa dia punya inflection point ni exist. Ada masa dia punya inflection point ni dia does not exist. Okay, ada dua kemungkinan. Ada dia macam you punya first derivative. Maybe you akan dapat maximum, minimum ataupun stationary point does not exist. Okay, sama saja konsep dia, hampir sama. Ya. Question 5 saya ingat tak ada masalah. Question 5 ni saya bagi jawapan saja. Equation of tangent ni mudah saja. You all check jawapan cukup. Ya. Ini you punya homework question 5. Saya tunjukkan method saja cukup. Ya. So equation of tangent, first here you find the dy over dx first step. Find the first derivative of the function dy over dx. And step 2 here, find the gradient of tangent or mt. And here you substitute the value of x into the first derivative here. And answer you here equals to the mt. Okay, step 2, find the gradient of tangent. And step 3, coordinates of the point. You find the value of xt and value of yt. Yeah, ini you all check pada step 1, step 2. And then last year you find the equation of tangent using this formula y minus yt equals to the gradient of tangent mt times x minus xt. Okay, dapat jawapan. Yeah. Equation of tangent, equation of normals, method dia sama saja. kecuali equation of normals, you cuma ubah yang kedua ini. Kalau equation of normals, second step, you just replace the MT, replace with the MN. Okay, step 3 sama, dan you punya ini pun sama. This one you replace with the MN. Okay, so the gradient of tension, gradient of normals here equals to the -1. So Mn here equals to the -1 over Mt. Okay, sama saja, ya. Kecuali you cuma ubah dia punya step 2 dan step 4 saja. Yang lain tu sama saja, ya. Equation of tangent, equation of mass sangat tak ada masalah, mudah saja, ya. Okay, ada 5 soalan. Saya cek dulu saya punya Q&A, ada soalan ke tidak. Okay, dalam masa 10 minit ni kita akan pergi ke Q&A. Okay, first soalan daripada Adawiyah. Can you explain about the special case relative extremum point? Okay, relative extremum point when the stationary point of the function does not exist. Kita patah balik ke first slide. Ni ya, mana tadi? Okay, special case first derivative. You punya stationary point here does not exist. Ini ya. Number 3 and number 4. Ini, this one. Number 3 and number 4. Okay. Ataupun satu lagi special case dia first year punya graph here increase and then after x equals to a graph here decrease. Yeah. This one x equals to a here. Okay. Ini sebagai contoh. Number 3. Saya tunjuk contoh. Okay. For example, ini contoh yang mudah. This one from the left here graph increase and after x equals to the -5 graph here decrease. Yeah. Dia akan dapat shape macam ini. Okay. So this one the stationary point of the function here does not exist. Sepatutnya you akan dapat increase, horizontal, decrease ataupun decrease, horizontal and increase. Ada dua kemungkinan. Yeah. Okay, number 2, explain how to find the intervals using the tables method. Okay, so this one saya ingat the inflection point. Okay, saya tunjukkan balik ya. This one you just draw the number line. Okay, so you punya number line here and the domain here all the real numbers negative to the positive infinity. So you just put the value of x equal to 0, x equals 2 and then you find the interval of the function. Yeah. Tapi kebiasaan dia kalau you punya point tu ada satu, you akan dapat dua intervals. And then kalau you dapat 2 point, you akan dapat 3 intervals. Dia mesti +1, kebiasaan dia. Yeah. Okay, number 3. The nearest value kena masukkan ke dalam original function ataupun the first derivative. Yeah. The nearest value you substitute into the first derivative of the function. Ini jangan salah substitute. You salah substitute, you akan dapat lain. Mana tadi saya tunjukkan. Mana tadi? This one. So the first value, the value of x here, the nearest value -1, 0.25. You substitute into the first derivative of the function, first derivative. Okay. Kalau you substitute into the function fx, you akan dapat coordinates of the stationary point. Okay, jangan salah substitute. Okay. Okay, and then the relative minimums 1/2. Okay, itu you check betul. Okay, correct. And then answer 1 is a negative 1/4. Okay, betul jawapan you. Jawapan dia adalah 1/2, negative 1/4. Okay, correct answer. And then, okay, this one okay. Okay, and then answer here, table of concavity must included in the working step. Yeah. Kalau untuk inflection point, memang dia punya step kat situ. Saya tunjukkan balik. Inflection point, ini. Yeah. This one, the table of concavity, this one you punya step 4. Yeah, masukkan sekali. Ada dalam step sini. You punya step 4, you punya table mesti buat. Yeah, kecuali you punya substitution tu. Substitution tu you all tak, just calculator sahaja. Macam ini ya. Saya tunjukkan balik lah. This one, you punya substitute ini pakai calculator sahaja cukup. Okay. And then you punya table ini memang kena lukis. Ini you punya method. Table of concavity. You kena tunjuk lah. Kalau you tak tunjuk, you tak tahu sama ada dia akan positive, negative, sign of the second derivative, or the graph here concave up or concave downwards. Yeah. Okay, and question 4b. Okay, and the question 4b. Okay, perbetulkan. Maybe saya, this one you all perbetulkan nanti. Ada 4b, cek balik. Okay. Question 4b, answer here equals to the 4/3, 70/27. Okay, itu you all check you punya calculator sahaja. Okay. Maybe ada errors kat situ. Okay, untuk question inflection point, question B. Okay, question B ni perbetulkan. Okay, perbetulkan jawapan dia. Okay, so ulangkan balik ya. So answer here 4/3, 70/27. Ini jawapan yang dibagi. Saya ambil saja. Okay. Okay, ada lagi soalan yang lain? Tapi hari ini saya akan keluar awal lah sebab you all lepas ini ada lecture berkenaan dengan English. Jadi saya kena keluar awal hari ini. Okay. Dan kalau you all ada sebarang soalan lagi berkaitan dengan slide, berkaitan dengan exercise dan sebagainya, you all boleh WhatsApp saya sahaja, lagi mudah. Ya. Okay. Okey, kalau tak ada soalan lain, saya ingat itu sahaja untuk hari ini. Dan Assalamualaikum warahmatullahi wabarakatuh. Okey, bye.
Okey, jadi untuk hari ini insya-Allah kita punya session kita akan dia tamatkan awal kerana kita dapat notification yang you all will be having something else going on soon at 3 PM. Hold on lah, ada satu soalan daripada Mr. Anonymous that I think I need to answer. answer for a while. But I guess the session is over. Hopefully that we can address majority of the question. Tapi kalau sekiranya tak, we do encourage for you to actually communicate one-to-one and also personally to Mr. Ibrahim lah. Just in case that there are some more questions that need to be answered ataupun clarified clearly. Okay. So mana tadi yang Mr. Anonymous ni punya soalan? Right, so in that particular case, you may always leave this session. Thank you and wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day ahead. So, polynomials. Attendance quiz. Okay, I didn't notice that one. Go back and check. Attendance session 5, attendance session 4, 16 February, attendance session 3, 15 February, 9 February.